This video will show you how to solve problem 47 in chapter 4 in the textbook. In this problem, it says the data for the number of cases of COVID-19 in the United States for the start of 2020. Here's the data, and we would like to use technology to create a scatter plot for the data. We're going to go ahead and use the TI-83. This is the 83 plus C server edition. It's going to be slightly different than yours, but not too much different. The first thing is you're going to go into the stat menu, which is the STAT. You're going to go into number 1, into edit and number 1 edit. If you happen to have data already in there, you're going to clear it out by just going up on the name, like I am right now, click clear, and hit enter, and it clears that column out. Go up, do the same thing, hit clear, and then hit enter. Then you're going to go ahead and type that data in. I actually typed that data in already, so I'm going to go ahead and put my data in, but you would have to go type your data in right now. Sorry. Yeah, get this in here, because you should be typing your data in right now. And I'll get my other data in there. So you're going to type in L1, you're going to type in your X values, which in this case happens to be the months. Then L2, you can type in your Y values, which in this case happens to be the cases. So you should have been typing all your data in. You should have it all in there nicely. And then you want to graph it. The first thing I'm going to do is go into Y equals. Everything we do graphing is in this top row. I'm going to have to type the Y equals just to make sure there's nothing already in there. There doesn't seem to be anything there. I do notice that plot 1 is on because it's dark. I want it on, but if you happen to have an error, you can just turn that one off. I'm going to go into second stat plot, or the Y equals. So second Y equals, get you in the stat plot. Then you go into number 1. You turn it on if it's not already on. What makes it on is the on is dark. The type we want is a scatter plot. So that happens to be just dots all over the place. That's this first one here. Our X list should say L1. That's where you put the X's, was in your L1 is your X values. Your Y list should say L2. That's what those should be. The marks are whatever marks you feel like having, and the color if you happen to have color. That's up to you. Now I'm going to go to zoom. When I go to zoom, number 9 actually says zoom stat, which means it will fit your window based on the data you typed in. So I'm going to go down to number 9 and either hit enter, or you can just hit the number 9 and it'll automatically do that. And then we get this wonderful looking graph. Now, one of the things I notice is it seems like there's a point here that's 1 and another point that's 1, and I don't think that that was my data. So I'm going to go back into stat, go back into edit, and just make sure that that value was right. And I noticed the first one should be 1, but the second one should be 16. So I obviously typed number wrong. I can just go down to number 1, that should be 16, just type 16 and hit enter. It will change it. Now if I hit the graph, it will actually have the correct graph. When I look at this, this looks like a logistic growth because it looks like it's starting slow, and it looks like it's going really fast, and then it looks like it's starting to level off. It's known as logistic growth. At the beginning of the pandemic, if you remember, they were talking about flattening the curve. This is the curve they meant flattening because we were going slow, then we're going really fast, and they wanted to flatten that curve. They wanted to make that curve go like this, where it's going off like that. So now what I'm going to do is I'm going to go into stat. I want to fit a logistic growth. So the next thing I want to do is I want to use technology to create an appropriate model for the number of cases based on the month. I'm going to go into stat, move over to the word calc, C-A-L-K for calculate. There's a bunch of different things we can do here. The LINREG AX plus B means linear regression. The QUADREG means quadratic regression, and so forth. These are all the different regressions we can do. If I arrow down through these, I'm going to find one that says logistic, and that's the one I want. I'm going to take that one, hit enter. My X's are in L1, my Y's are in L2. Don't worry about the frequency list. But I might want to actually use this regression equation, so I want to store it. So to make sure I can store it, I want to store it in the y equals. To access that, I'm going to click on the vars button, the VARS button for variables. When I do that, it gives me lots of different choices, but I'm going to go over to y variables because I want to put in the y equals. So I'm going to go to y variables and pick number 1 because this is a function. And it doesn't matter which one you put it in, I might as well put it in y1. Now what I'll do is I'm going to hit calculate. It will calculate that equation. It will then store it in the y equals, and we'll be good. So I'm going to hit enter, calculate. It will then do some calculations in the background, and it comes up with this equation. So tell me y is equal to c divided by 1 plus a e to the minus bx. A is equal to 243.1, b is equal to 0.496, and c is equal to 3,000, I'm sorry, big number, 375,422,05202. So I'm going to go ahead and write that up. That's my equation. I wanted to create that model. That is my model. So now I can actually type over here, or on your piece of paper, you can write y is equal to c, which is the 375,45202. If you want to, you can keep going. You can write 0.1, 0.2, I mean, but I wouldn't write all the decimal places. That was my C. C is divided by, so I'm going to write divided by, and then parentheses. 1 plus my A. A is the 243.1. Again, I don't want to write all the decimal places at this point. Times E to the, and E is a number. It's not one of my parameters. These are my parameters I'm getting. My A, B, and C are parameters. E is a number. And I'm going to just write E, and then the caret, which is above the number 6 key on your keyboard if you want to type it, is what makes a power. And then in parentheses, I'm going to put minus my B. My B is 0.496. I'll probably take it that many places because if I don't, if you're rounding, it'd be 0.5, and that's probably a little too small. And so I just want to go a little bit farther. And then X, because X is my variable. So there's my equation, there's my model. The next part asks us to determine the R-squared value from your model. Unfortunately, the calculator won't get the R-squared value for the logistic model. It will do it for some of the models, but not the logistic model. So you won't be able to do that for this part of the problem. And there are other ways to do it on Desmos, but we can't do it here. Then I want to use your model to estimate the number of cases of COVID-19 in the United States 18 months after the start of 2020. So first thing I'd like to do is I'd like to see how good does this model meet it. If I hit y equal, there's my equation I just came up with. It actually typed it all in there for me. It kept all the decimal places, so the answer will be a little different than the one I'm going to have. If I press graph, it then plots that graph with my data. So you can see it actually does a pretty good job of modeling my data. I would like to actually estimate the value in 18 months after the start of the pandemic. So if I actually go into the calculate button, which is above the trace button, if I hit second calc, I can actually calculate a value. So number 1 will actually calculate a value. It'll ask me what X value I want, and I wanted X 18 months. So I type in 1.8. Okay, that's interesting. Didn't know that it was going to do that. It won't let me do that. Okay, probably because it's off my graph. So we can't do it this way. So we're going to do it a different way. So we're going to go second quit. And we're going to actually, remember we put that vars button in. So we're going to go back to that vars button, go back over to y vars, number 1 for function, and then y1. And this is basically function notation. So y1 is my function. If I put a parenthesis, it'll put functional notation. So now if I do 18 and close my parenthesis, it will then calculate my value. So that's how many cases there were. And this is again the total number of cases. So that's how many cases there were at the start at 18 months since the start of 2020. The question is, should the value be trusted? So one thing I'm going to point out is that when I tried to use my calculator, it was off where the data was, and it gave me an error. So that means that this value actually does not fall within the data we were given originally. So I can't find out what it is in that year from this. And that kind of tells me it probably shouldn't be trusted because it's kind of outside my data. It may be okay to trust. It was before the widespread use of the vaccination, but it may not be trusted. So we're going to just go with you probably shouldn't trust it because it's outside the original data. Then we want to use this model to predict the number of cases 24 months after the start of 2020. So again, we're going to do the same thing. We go to VAERS, Y-VAERS, function number one, and then in function rotation, I'm going to do a parenthesis and I'm going to type in 24. Close that. And this is how many cases there were in that 24 months after the start of pandemic. Again, this probably shouldn't be trusted because at this point, the vaccination was more useful and other things were happening. Plus, it's outside the original data. So you want to look at it being outside the data. You don't know that that model still works.